Okay, I intentionally stopped it because that was the summary of kind of finishing up acid-base titration curves. Here is acid-base indicators 15.5. And again, I already said it in another video, work number 33 and number 3. You should be able to work all of this from all that I taught you in the past lessons, but you don't have to do it. You can go and look at the answer key later. But as I mentioned in the last video, if you're like, hey, I want to make a 5 on the AP, well then you want to do 39 and 40, and you at least really want to study the titration curve of the base, the number 2, the number 2 problem. Okay, this ought to be fairly short, and it's kind of a easy, kind of interesting, I hope, fun thing. Oh, and it would be so great if we could have done some lab experiments to show you this. Okay, so acid-base indicators. Well, there's only a couple of things I think you really need to know about acid-base indicators. First of all, the main indicators that you should all be aware of is litmus. Now, remember that litmus in acid, it is red. In base, it is blue. I think I mentioned that on the other video. Now, the way they do it, they have red litmus paper and they have blue litmus paper. There are two. You may have seen them in biology class, red and blue. It doesn't matter which paper you have. If you put it in acid, it will be red. So red paper in acid will stay red. But red paper, if I put it in base, it will turn blue. The paper turns blue. Blue paper, if I put it in acid, it will turn red. Blue paper, if I put it in base, will stay blue. So it doesn't matter whether you have blue or red, that's what happens. There's another one called phenyl Phthalene. Now, this is the one I showed you in a video during the titrations. That in acid, it is colorless. Now, if there's not enough, it has to dissolve in water and alcohol. You don't have to know that. But if there's not enough alcohol, then it will precipitate and get cloudy in a little bit. And that's why you saw that. But it should be no color in acid. Oh, and by the way, in water, these are the same. You know, these just stay red. Nothing happens. So if you put red paper in acid and it stays red, that might mean you have acid, or it might mean you have water. It'll also be the same color, okay? Anyway, phenolphthalein is colorless in acid. In base, it is magenta, kind of a pinkish purple color, really neat. Okay, and then the other one, okay, those are the two that are most common that you probably should know about. Bromothymol Blue, I'm going to talk about that a little bit. Now, what can happen is this. They can give you on the AP, they can name an indicator. There's one called Congo Red. There's one called, I think, Alrazine Yellow. And they all do neat things. One color in acid, one color in base. I really like the Bromo Blue because I think it kind of explains indicators the best. But in acid, and it has to be pretty strong acid, it is yellow. Or it can even get red in the strongest. I don't know. That's another, that kind of goes against what I'll show you. But it's yellowish. And in base, it is blue. So you can get yellow, orange, red color. But yellow, we'll say acid, and base in blue. In base, it's blue. Bromo Blue is blue in base, just like litmus is blue. But then there's also something called Bromothymol Blue. And there's another kind of one, blue also. I can't remember the name of it. But well, there's crystal violet. There's a lot of names. What they normally do on the AP, though, is this. I would say you should know these litmus and phenolphthalein, but they're going to give you this, and they'll even tell you what colors, perhaps. I'll show you how it works. But they're going to give you a list. If you look at on the next page, it says indicator, crystal violet, bromothymol blue, methyl red, phenolphthalein, phenol red, alrazine yellow, and they give you the pKa. Like, what does that mean? Why are they giving you the pKa? Remember, the pKa is when the base and the acid are equal to each other, right? In a weak acid. All of the indicators are weak acids. And they all have a pKa, pKb. pKa, they all have a Ka value, and for that matter, a pKa. Now, for phenolphthalein, it is 8.7. That seems a little bit wrong to me. No, I think that's right. That is right. 8.7. And for bromothymol blue, it is 7.1. So here's the quick, easy thing to remember they like to ask you on AP, multiple choice question. They'll give you a bunch of these. they'll say, which one of these would be the best to use if you're doing a titration of a strong acid into a strong base. A strong acid to a strong base. Okay? Well, what you do is you got to think, what is the pH at equivalence point? Strong acid and strong base at equivalence point, pH is 7. So you want to pick the one that is closer to 7. And I say closer to 7. If they gave you that list, the best one would be to use Bromothymol Blue because it's 7.1, it's pKa. The pKa should be the one that's closest to the equivalence point pH. Okay. And did I write that? That's interesting. I don't think I even wrote that somewhere, but I should write that. A big statement, important. Now, let me show you one more thing. Let's just say that we only had the bottom. We didn't have Bromothymol Blue. Between methyl red down, which one would you use? Well, I guess in that case, phenol red is 7.7. That's pretty close. So you don't have to always, but anyway, you try to get one that's closest to where the pH, best indicator, will have a pKa equal to the pH equivalence point in your titration. So you need to know you need to estimate what the pH will be at equivalence point in your titration, and then use a pKa. Use the one that has a pKa closest to that number. Like if pH is 7, use pKa 7.1. Okay. Can you remember I said the most common titration, if you add a strong base to a weak acid at equivalence point, it will be, can you remember? It'll be basic. It'll be basic. So a little bit basic, that means it might be good to use phenyl phthalene. Look at that, 8.7, so it's in the basic range. So that would tell you why phenyl phthalene would be good. Is good to use when you add a strong base to a weak acid. The most classic titration they give. Okay, so that's one thing to let you know about. And there's only one more thing I'll just show you. This is what I'm showing you right now is probably all you're going to need to know pretty much about indicators. But there's one more thing I want to show you. Like I'll use for Bromothymol Blue. Every indicator is an acid. And remember we have HA mixes with water or whatever, or breaks down into H plus and A minus. Well, sometimes I like to write hind. This would be the negative one of the indicator anion, and that would be the positive one. And then it would break up into H plus and IND negative. This is the same as the top. It's just we're doing that with the indicator. So here's how it works with Bromothymol Blue. This is an acid. This is a conjugate base. I could have put water in there, I guess, to make it a little bit better there, but oh well. So, how does it work with Bromothymol Blue? If you add acid, we said, then it is yellow. Well, when you add acid, what happens is you're adding H plus. H plus will react with that, and it sends it this way, and that one would be yellow. If you add base, you get that one, it's blue. So I'll just show you an example. So what you should do, you should imagine indicators are like buffers. They really are buffers, because what happens is you have both things present. Now, what would happen, you think, for Bromothymol Blue? If I have equal amounts of yellow and blue, what color will that be? Green. And look at this. So right around pH of 6 to 7 or so, it is 7.6 actually, it is green. So when you have equal amounts of yellow and blue, it's green. Bromothymol Blue, the color. But if I have too much acid, it's yellow, too much base is blue. Why? What if I add H plus? Think about a buffer. You add H plus is going to react with the acid or with the conjugate base. It'll react with the conjugate base. So H plus will react with indicator negative to make acid, HIND, that is not broken up. So what happens is, you could also think of a Le Chatelier. If I add more of this, then you're going to cause it out of balance. It's going to have to shift to the left. it's going to eat away that. It's going to combine with that, and this is going to decrease, and you're going to have a lot more of that. You have a lot more yellowish color. Yellowish color if you add acid. If you add base, that means OH negative. Guess what? It won't react with the base. It'll react with the hind, the acid, and to give you water and the indicator base form. So you add base, it reacts with that, and if you add base, what happens is it diminishes the IND. It takes that away, and instead, what happens is, well, that one, if you thought about Le Chatelier, you would think it would go the other way, but oh well. The OH reacts with that, takes away this. If you decrease this amount, it's blue. Just like if you decrease this amount, it's yellow. Probably it's better to think of it that way. So if acid is added, it decreases the IND and it becomes yellowish, more yellow. If base is added, it decreases the acid, it becomes more blue. Okay, that is it really. That's all you need to know about the indicators there. Okay.